Good afternoon. Good afternoon. In the yesterday class, we already completed about COMP, component, COMP2. In today's class, we'll see COMP3. So COMP3 is also one of the memory reducing technique and computational variable. So the data will be stored in form of packet decimal, packet decimal format or hexadecimal format. In COMP3, each digit will take half byte and sign will also take half byte. Okay. In COM3, data last half byte will it is called as flag byte. The flag byte purpose is to store the sign values. Flag bytes are so representation of flag bytes. Positive means C, D means negative, F means unsigned value. Unsigned we can also call it as positive only now. Okay. Respond.
Yes, ma'am.
So the size of flag byte is half byte only. In computational variables, memory calculation will be based on the picture class length. Okay, if it is a numeric, if it is even, the formula for even is n by 2 plus 1. If it is odd, n plus 2 by 2. Okay, let's see some examples. So declare a variable WSA picture class S9 of 5 com3. Okay, so 5 is odd. So what is the formula for odd? N plus 2, n plus 1 by 2. So you can write 5 plus 1 by 2. It is 6 by 2. 6 by 2, 3. So the length of WSA is 3 bytes. So next example, the picture class length is 12. So what is the formula for even n by 2 plus 1? So 12 by 2 means 6. 6
is
plus
even
1, 7. What, Nikita?
it is even now.
Even.
So n by 2 now.
N by 2 only. 12 by 2 is what?
Okay, plus 1 is there.
12 by 2 plus 1, 7. Okay. So maximum value for maximum number of bytes for comp3 is 10 bytes. So for numeric, what is the maximum range? 18 only no. 18 is even. 18 by 2, 9 plus 1, 10. Okay. The maximum bytes is 10 for comp3. Okay.
Yes,
Clear?
ma'am.
So this is how to know the how many number of bytes for picture class if it is odd or even. But you forgot it this formula n plus n by 2 plus 1 and n plus 1 by 2. Now what to do means, so I already told that uh, sign will take half byte and in com3 each digit will take half byte. Based on this you can also find how many number of bytes. Sign will take half byte now. S is the sign 0.5. Okay. So S numeric picture class length is 5. So each digit will take half byte now. 5 is half is what? 2.5. Okay.
Yes.
You can calculate this both. 2.5 plus 1.5 will get 3. Okay.
Yes, ma'am.
Same example we have seen here. Okay.
Yes, ma'am.
Sign will take half byte. It is 0.5. Now 12. 12 half how much? 6.
This
6 plus 0.5, 6.5. Approximately 7. Then
round up.
7 bytes. Okay. Next, sign will take half byte. 18 half 9. 9 plus 0.5, 9.5, approximately 10 bytes. Clear? If you forgot the
Yes, ma'am.
formula also, we can also know how many number of bytes it is calculating in the COM3. Okay, each digit will take half byte and sign will take half byte. Clear?
Yes.
Yes, ma'am.
So declare a variable with S9 of 5 COM3. So comp L equal to length of WSA, we can get 3 bytes. So now I am moving 5, 7, 8, 9. I am moving 4 bytes value to 5 bytes. Okay. It is numeric, no, it follows right justification and 0 will be there in the starting. You already know about this now. So internal representation of COM. First, in this place, 0 will be stored. Okay. Next, 0 move to up and 0, 5 will be stored. Okay. Next, 0 move to here. 0, 5, 7 will be stored. Again, 0 move to up. 0, 5, 7, 8 will be stored. Now 0 move to here. 0, 5, 7, 8, 9 will be stored. 0 move to up. 0, 5, 7, 8, 9 will be stored and last is the slack byte. So F is the slack byte. You don't specify any sign value for this value now. Okay. If it is a positive, we'll get C. If it is negative, we'll get D. So we don't specify any sign value now. So that's why we are getting F as a slack byte. Okay. So this is the flow of internal representation of concrete like this. Okay. Like
Yes,
this,
ma'am.
the data will be stored. Clear?
Yes, Mani.
So the packed or hexadecimal value for 578 is 05789F like this. Okay. So in the spool area, you can see like 05789F. If you want to see like this in the box means you need to type set hex on in the spool area to see the hexadecimal values for given data. In the command line, we need to type set hex on. If you want to off the hexadecimal values, you can type set hex off in the command line. It will normal. Okay. So coming to COM4 and COM5. So before coming to COM4 and COM5. So in COM4 and COM5 it is data will be stored in form of binary format. Previously we already seen data stored in form of binary format in the COM, right? In the comp also data will be stored in form of binary format only now. In the last class we have seen.
Yes, ma'am.
So there, so if you want to store like if you want to store less number of records, then we can prefer the comp. If you want to store more number of records, then we can prefer this comp 4 and 5. Okay. Comp 4 16 bytes, comp 5 32 bytes. So see here, if you want to store more number of digits of binary format, then I can prefer comp4 and comp5 to avoid the data truncation. Okay, if you store more number of digits in the comp, so there is a possibility of data truncation. That's why we are going to use comp4 and comp5. So if you want to store less number of digits in binary format, then you can prefer comp. Okay. If you store more number of records in the comp, there is a data truncation possible. In comp4 and comp2, it is not possible. Okay. Respond, please.
Yes, ma'am.
Note the comp and comp2 data will be in the readable format in the file. By using sort utility or comp display statement, we can convert into readable formats. So in the year of Jan 2025, there is a one employee. Okay. So what is the figure? Total number of bytes 26. How means? So EID is 4 bytes, E-name is 15, E-salary is 7 bytes. How means? Picture class length is 5 and after decimal you want 2 bytes. Total 26 bytes. Okay. So you can also write decimal like this also. Means in place of V99 you can also write V9 of 2. Okay. So here EID will carry 4 bytes and store only 4 digits. E-salary total length is 7. 5 plus 2, 7. So total length is 7 bytes. Before decimal 5 and after decimal 2. Okay. So in the Jan 26, same picture class length by using comp. Here we don't use any comp in the 2025. Here we are using comp. Okay. So his name is 15 bytes. His salary 11 plus 2, 13. Okay. It is comp 3. So EID will carry 4 bytes and store 5 digits in that. And e-salary 7 bytes. Before decimal you can write 11. After decimal you can write 12. Okay. Hello.
Yes, ma'am.
Clear about this example?
Yes, ma'am.
So can you please tell me how the 7 bytes are there in this e-salary? How 7 bytes are?
Like
Hmm.
it is like 11 for 11 it goes to 5.5, and for 2 it 1, then it will be 6.5 and round off will be 7.
Okay, like this you can say, and on the by using formula
Yeah,
11,
formula
11 plus 2, 13,
Yeah.
13 plus 1, 14 by 2,
is equal to 7.
14 by 2, 7. Like this also you can say. Okay, so comp, it is a pure integer format. Example for comp is EID or account number, policy number, mobile number, and product IDs. For comp 3, it is decimal data like amount, field, salaries, and package, etc. Okay, package means your salaries package. Okay,
Yes, ma'am.
so data allocation table for computational variables. So while passing the data means data allocation, you already know about the value class, except statement, and most statements. Okay, you have to pass the data in comp, comp1, comp2, and comp3. Okay, if possible means you can tick like this. If not possible means you can tick wrong in that place. Okay. Complete these examples. Okay.
Okay.